Okay, hello and welcome to another video on this time on the Pure Mock Solutions Part A. I'm just going to do the first 9 questions, or we'll see how far we get. Okay, this first question you do not want to be losing any marks on. Yeah, I can almost forgive you for losing 1 mark for not having the plus C on it, but everything else, you know, this is a bog standard basic integral question. We just increase the power by 1, divide by the new power, increase the power by 1, divide by the new power. Numbers just go to numbers times x. If you like, it's 7x to the 0, and we're still increasing the power by 1 divided by the new power. And then because we haven't got limits, we put plus c on it. If there was limits, then there's no plus c because it actually takes a value, and that value represents the area between those limits. Okay, they did want it in simplest form though, and so we do need to change that 6 over 3 into a 2. And there you go. That is the final answer. So you should be getting 3 marks on that. Okay, 2 is harder because it asks for the range. Now, I always think with range, like drawing it is the best way to do it. It really is. Like it's really difficult if you don't draw it. It really is. So you want to draw it basically. That's the key thing. You really want to draw the diagram. You can kind of get there without drawing it. Don't get me wrong, but you know it's much easier to draw it. So let's talk about how we draw a function like this. It's not an easy function to draw really, but one thing you can do, and this is just a good habit to get into when sketching graphs, is you can think, well, when x is 0, y is going to be 0. So it's definitely going to go through the origin. Next thing you can do is you can look at behavior when x gets really large. Now let's say x is like 1,000,000. What is 12 million divided by 3 million add 4? Well, you don't need to know it exactly. You just need to know, well, 12 million divided by 3 million add 4 is basically 12 million divided by 3 million, which is 4. And so that's the way of identifying horizontal asymptotes. You look at the behavior at for very large numbers of x, or for very large negative numbers of x, in other words, very small values of x. And then you can see that this graph basically is going to be between 0 and 4, as we draw the curve. You might think about a few more things, like, what about x tends to negative infinity, where you've got minus 12 million divided by minus 3 million add 4? Well, that's going to be minus 4. Sorry, did I? Oh, no, it's going to be at 4 again. Excuse me. Getting the diagram wrong. We're only drawing it anyway, actually, for x is greater than or equal to 0, so I don't really need to know that. So I just know my graph's going to, because it goes through 0, and as x gets large, it gets close to 4. It's going to do something like that, yeah? And you can draw it on GeoGebra and see what it looks like. I haven't actually done that yet, but I know it's going to be, and I can see it's going to be just under 4 as well. You might be saying, well, how do I know it's not over 4? Well, that's because 12 million divided by 3 million add 4 is just under 4. And you can try that on a calculator if you don't believe me. Okay, so hence the range is going to be 0 is less than or equal to f of x, which is strictly less than 4. Yeah, that's quite a difficult range question though. Okay, find f to the minus 1 of x. Now, this is not f dash of x, is it? This is find the inverse. Look carefully at the notation. And the rule for finding the inverse is you can either swap the y's and x's at the start or at the end. Let's just write the function down first. I'm going to swap at the start, I think, but it doesn't matter if you swap at the start or at the end. And then I've just got to make this y equals, yeah? So I'm going to times that over there. I'm going to get 3xy plus 4x equals 12y. Remember, I'm trying to group the y's together here. 4x equals 12y. Oh, I've written 12x. 12y minus 3xy. Now I factorize it, so I get 4x equals y times by 12 minus 3x, and hence y is 4x over 12 minus 3x. Now make sure at the end you tell the examiner you know that's the inverse function, or they won't give you the mark, yeah? You've got to tell them this is the inverse function, 4x over 12 minus 3x. And obviously you can have this all upside, negative 4x is 3x minus 12. There are equivalents. Okay, and so that's that one done. Show that for x is a member of the reals that f of x is this. Well, this means we're plugging f into itself. So f of x equals 12 times by, now that x is going to become a 12x over 3x plus 4, divided by 3 times 12x over 3x plus 4 plus 4. Yeah. Now, if I'm simplifying this, I'm going to times top and bottom here by 3x plus 4. It seems like the obvious move. That means you're just going to be left with 12 times 12x, which is 144x. Yeah. And tell the examiner what you're doing as well. Let's make sure they know we're timesing the top by 3x plus 4. And we're timesing the bottom by 3x plus 4. Yeah, just to let them know. Okay, when we times this by 3x plus 4, that just becomes 36x. And then this 4 needs to be times by 3x plus 4 as well. So you're going to have 12x plus 16 there. And so that gives us 144x over 48x plus 16. And now if we divide the top and bottom by 16, we get our answer. We're going to get 9x over 3x add 1. Yeah, and sign off with a little as required. You know, remember, you're communicating with the examiner, letting them know that you understand why that is the same as that. So make sure you do. Okay, this question. Identify the error in line 3. Okay, so something's gone wrong, and I think it's gone wrong here. Yeah, when you go from there to there, sure, you get x squared minus 27x, but you get a plus 3x squared. So you just have to say minus 3x times by 9 minus x equals minus 27x plus 3x squared sign error. Yeah, make it really clear. You know exactly where the error is there. Okay, using algebra and showing all your workings, solve the equation simultaneously. So what we got? We've got y is 9 minus x, and we've got x squared minus 3xy plus 2y squared is 0. And so that's going to give me, if we swap all y's out, minus 3x times 9 minus x, they've already done this work for you, plus 2 times 9 minus x all squared equals 0. Don't be lazy. If you don't write that in there equals 0, you could easily lose method marks, yeah? You're losing method marks when you do that. You must use the equal sign properly. Okay, multiply it out. X squared minus 27x plus 3x squared plus 2 times 81 minus 100 minus 18, sorry, x plus x squared. We'll double all that now. Let's simplify it all now. We've got x squared and a 2x squared, that makes a 3x squared. Oh, plus another 3x squared, that makes a 6x squared. Yeah, I do this little ticking thing when I've dealt with that term. Then I've got minus 27x minus 36x, and I think that comes to minus 63x. So I've dealt with that one, and I've dealt with that one. And then I've got plus 162. So I've dealt with that one. Check you've dealt with all the terms. You can simplify this, but to be honest, in this kind of exam, you're also allowed to use your calculator. But then again, it does say showing all your working, so maybe we should be slightly more careful and write this as 2x squared minus 21x plus divide that by 3, and we're going to get 54. And therefore, it factorizes to give 2x minus 9, x minus 6, and it's just because it said showing all working, I want to show this really. So x is 9 over 2 or x is 6. You can easily work out the corresponding y values because x plus y is 9, remember. And so that must be a 3, and this must be a 9 over 2 as well because it's 4.5. Yeah. Make sure you sort of like group them, you know, because they are paired solutions, aren't they? And you can write them as coordinates for that reason, you know, just to show that you understand which one pairs with which one. Sometimes it can be a bit ambiguous looking at students working which pair is which. Okay, right. What we got here? Got a quadratic, yeah? They just confused you by putting a K in there. That's all they did. You know, I've got more sympathy for you on the applied paper where I thought the mock was genuinely really rather difficult. On the pure, less sympathy really. This one, you know, we're just sketching a quadratic and it's upside down. If you multiply out those brackets, and feel free to, you know, minus x squared plus, right, well, we've got, let's have a look, plus 2x minus kx plus 2k. Yeah, that's what we're actually dealing with here. Right, sketch C. Yeah, so label your axes. Yeah, and then think it's an upside down quadratic and it goes through minus k and 2. Yeah, so that'll be minus k, and that will be 2. And when x is 0, y is going to be 2k, so you must put 2k on the y-axis, yeah? I really can't see if there's anything more to this question than that. I don't think so. So we'll go on to B. Find in simplest form in terms of k the coordinates of the stationary point of C. Yeah, this is actually a little bit awkward, yeah? But stationary point, so we're going to differentiate. That will give us minus 2x. It is possible to do this by completing the square as well. But you're going to get minus 2x plus 2 minus k. Stationary points where this equals 0. So you're going to get 0 equals minus 2x plus 2 minus k. And that gives you x equals 2 minus k over 2. Yeah, happy with that. Now, that would have got you most of the marks. There's only one more mark to get. The last mark is difficult. That's what I was going to say. Just to put it in a nice form. If you use the original, it's actually slightly easier. So we're going to have 2 minus k over 2 plus k. And then we're going to have 2 minus k over 2, yeah? And if you work with this, well, that k is actually 2k over 2, so I can rewrite that just so it's got a common denominator as 2k over 2. I'm going to do the same with this 2 here, just so we've got a common denominator, and write it as 4 over 2. And now I can easily add them together. 2 minus k plus 2k, well, that's 2 plus k over 2. And this ends up being the same thing, because remember that this is basically in brackets. 4 minus 2 is 2, then the minus k is plus k. So you get 2 plus k over 2. In other words, your y value is 2 plus k all squared over 4. And it's done. Or any equivalent to that you could have had. Okay, right, number 5. This one, it's not too bad. It really isn't. Like, the simplified surd should be fine. Remember that when they give you these, they're giving you position vectors OA, OB, and OC. And AB, the length of AB, is just going to be, let's find AB first, and AB just equals OB minus OA. Handwriting's getting bad again. And so that's going to be right in column vectors. It's a lot easier. I'm going to explain afterwards why this has like a nicer way of thinking about it, really, but it doesn't show any working. 5, 3 minus 2. And so we get 7 minus 5 is 2. 1 minus 3 is minus 2. 2 minus 2 is 4. Yeah? Now, can I point out, look at the notation, A to B with an arrow on it. It's just how you get from here to here. Add 2, take away 2, add 4. Yeah, like, it's, vectors are obvious when you look at them like that. The notation's really handy. Now, we wanted the size of AB, yeah, and so you really had to, I think in the mark scheme they were really quite harsh here and said, if you want a method mark, you have to start Pythagoras, yeah? So we're going to use Pythagoras to find the length of that vector. 2 squared plus minus 2 all squared plus 4 squared. Yeah, be careful with the minuses. I think they actually wanted you to plug that in as a minus 2 squared. I think it said it in the notes. And so make sure you show everything. Okay, it gives you 16 plus 4, which is root 24. But they want you to simplify the surd. That's 4 times 6, so that's 2 root 6. Okay, so that was that one. Okay, the next one. I feel sorry for you a bit here on these ones. Because with 3 points, yeah, you can actually put a fourth point in 3 different places to make a parallelogram. And that's exactly what I'm doing now. It forms basically a triangle with these points as medians. Do you see what I mean? Because that would be a right angle. Sorry, that would be a parallelogram. That would be a parallelogram. And that would be a parallelogram. However, now I've said that, this is why I feel sorry for you a bit here. However, it is customary. In fact, it is the way it's always done in Edexcel, at least anyway, to label your points like this as a cycle: A, B. Let's put this one over here: C, and then D. Yeah, you can do it the other way around, A, B, C, D, and I think you should get the same answer. But it's customary to go around in a cycle like that whenever you're dealing with polygons on a graph, basically. And if you do that, there's only one place D can go. Yeah, so if you got up another answer. It may well have been a possible answer, but with a mislabeling of a parallelogram. They seem to not accept that, from what we can tell anyway. They don't accept that, so be careful. Anyway, I'm just going to write these down as coordinates. 5, 3, minus 2. B was 7, 1, 2. C was 4, 8, minus 3. Okay, now in the old paper where I saw them ask this question, there's like a really old one from like 2006 or something, where they asked exactly this question. They did accept a good diagram as you're working. So once again, it's all about the diagram. Now, I would put it like this. I draw a diagram like this, and I could have used other parallel vectors here, but I'm just choosing to use BC and A to D. BC vector should equal the AD vector, yeah? And BC equals, well, by look at that, minus 3, yeah? And that's 3 up to 8, so that's 5. That minus 3 looks really bad. Minus 3, 5, and then 2 to minus 3 is minus 5, yeah? So that's the vector I'm going to use, basically, here. Is that... Oh, no, that's a 1. Sorry. I'm misreading my own handwriting. Have you ever done that? I've definitely done it, which changes this, because 1 to 8 is actually going to be 7. So let's just check this again. Drop 3, up 7, drop 5. Yeah, so it's 3, 7, minus 5. Now, we need to do exactly the same thing to get to the D answer, yeah? So I'm going to drop 3 from 5, which is 2. I'm going to increase 3 by 7, which is 10. And I'm going to decrease minus 2 by 5, which is minus 7. And that will be the answer, essentially. You might want to write it down. If you want to show more working, you might want to point out that OD is just going to be equal to OA plus AD, plus AD, and AD of it, of course, BC. And so you've just got the position vector of A, which is 5, 3, minus 2. And then I'm adding on AD, which is minus 3, 7, minus 5. I honestly think, though, it's less work and it's easier to just do what I did on the diagram there. And apparently in the old paper they accepted it. Okay, last question. Point E is positioned such that ACE is a straight line and AC to CE is 2 to 1. Find the coordinates of the point E. Okay, right, very well, very well. Okay, so let's just remind ourselves of A's coordinates. I prefer to write down the coordinates. 5, 3, minus 2, I think it was. And C's coordinates were 4, 8, minus 3. It's at the top of the screen. And we know that like AC to CE, let's label this diagram, is 2 to 1, yeah? So that's 1, that's 2. So let's just find the vector AC first. It is drop 1, increase by 5, drop 1. And so therefore CE is going to be half of that. So minus 0.5, 2.5, minus 0.5. And so OE, very similar to last time, is just going to be OC plus CE. And as OC was 4, 8, minus 3, I'm going to end up with an answer of, it's annoying writing it all down, 3.5, 10.5, and minus 3.5, yeah. Okay, let me just check the answers on the other page. Oh, they wanted it as a coordinate. Okay, well, I'll write it on its side then. 3.5, 10.5, minus 3.5. Watch out for that, yeah? Sometimes they ask for a coordinate, sometimes they ask for a vector. You really should do the right one out of the two. Okay, number 6. Okay, I saw loads of people baffled by this, and it really isn't that bad. And actually, it's in the textbook. So there we go. Okay, what I'm going to do, we know that this area, we know that the triangle area OAC to area of the segment, a segi is just the end here, yeah? So this is 3 to 1. That's 1, and that's 3. The triangle area is 3 times bigger than the segi area, which is just this bit on the top. Right, let's talk about the area of the triangle. Okay, that's a half AB sine C. Yeah, let's talk about the area of the segi. That's going to be a half. Now it's going to be the sector minus the triangle. So the area of the sector is a half times 12 squared times theta minus a half times 12 times 12 times sine theta. Yeah. And so let's just simplify those. This comes to 72 sine theta. And this comes to 72 theta minus 72 sine theta. Cool. Now, what do we know? We know we need to multiply the segi by 3 to get the triangle. Yeah, and unfortunately, you didn't get a method mark till you set up a correct equation. We need to multiply this bit by 3 to get to this. Yeah, so 3 times 72 theta. Oh, my handwriting's gone poor. Minus 72 sine theta equals 72 sine theta. Personally here, I divide everything by 72 and ignore the 3. So I'm going to get 3 times theta minus sine theta equals sine theta. You could multiply out the brackets first if you want to do that first. So 3 theta minus 3 sine theta equals sine theta. Or in other words, 3 theta equals 4 sine theta. I've forgotten what I'm showing. What am I showing? Okay, 3 theta minus 4. Oh, yeah, so I should have just taken that over there. Let's just get rid of that last line and take the sine theta on there, and you've got the answer. So 3 theta minus 4 sine theta equals 0 as required. There we go. Okay, what's next? Number 7. Let's do this. Have I got time for this? I actually have some tuition in 10 minutes. I might have to pause the video here. Can I pause videos on this? I can. I'm going to pause record. Okay, where was I? I think I was doing question 7. Okay, so this one's a little bit more awkward. A ball is released from rest from a height of 5 meters and bounces repeatedly on a horizontal ground. After hitting the ground for the first time, the ball rises to 3 meters. In the subsequent, its height bouncing 60% every time. Well, it's actually bounced 60% there, hasn't it? So this is times by 0.6 times by 0.6 times by 0.6. This is about geometric sequences. Yeah, that's the first thing to recognize. It's about geometric sequences. But actually, for part A, you're almost better off just doing it kind of like with a little diagram showing what's going on. We've got 5 meters falling on the way down. Then it's bouncing 3 meters up, 3 meters down. Then it's bouncing 1.8 meters up, 1.8 meters down. In fact, let's just write down that number once because you can see with the arrows that they're the same length. And then it's bouncing, and you can even put on this first bounce, second bounce, first, because that's the first bounce. Yeah, this is the second, this is the third. Yeah, and so if you want to know the maximum height after the third, then you need to do it once more times by 0.6, and you're going to get 1.08 up and down. Yeah, that's a fourth bounce. And so how am I going to show that? Well, I'm just going to do like 3 times by 0.6 equals 1.8. And I'm going to do 1.8 times by 0.6 equals 1.08 meters. I think that's really all they wanted to see. I'm just going to check the mark scheme now to see what they actually wanted to see here. Let's have a look what we got. Yeah, they would have accepted like anything like that, really. They just wanted this to be repeated twice. Okay, find the total distance the ball travels from release to when the ball hits the ground for a 5th time. Well, we've got 4th here. That's a 4th time. 5th time, I'm trying to draw the arrows even smaller. We're going to have 1.08 times by 0.6, which is which is 0.648. Let me just get this right. 0.648, and you can do that on a calculator to check. Yeah, and so if you've got to find the total distance, well, what have we got to do? We've got to do 5 plus 2 times, 3 plus 1.8 plus 1.08 plus 0.648. And that will just spit out the answer, and it gives you 18.056. But we always should be writing everything to 3 sig fig, so roughly equals 18.1 meters. Yeah, and that is the final answer, 18.1 meters. Sorry about my handwriting today. That's better. Okay, according to the model, after the ball is released, there's a limit, d, to the total distance travelled that the ball will travel. Well, this is about geometric sequences, it really is, and so we need the sum to infinity formula here, but let's just have a look at this, because what have we got? We've got 5 plus, and then if we do the 2 times 3, that's 6. If you do the 2 times 1.8.6, that's 3.6. If you do the 2 times 1.08, it's 2.16, yeah? And let's just put plus dot dot dot. Now, this is a geometric sequence, but the first term only appears once, so you're almost better to leave this out because everything else has been doubled. So this is the same as 5 plus. Now we've got a geometric sequence here. Now the sum to infinity is a over 1 minus r. So if I have the first term as 6 and the common ratio is 0.6, because it'll be 0.6 there, then it avoids that confusion, because the problem with a 5 is it's the odd one out because it's only happening once because you're dropping it from 5 meters, whereas everything else it's going up and then down, up and then down, up and then down. And that's the reason I've broken it up like that. And anyway, that comes to 20 meters after you work it out. And then with reference to the model, give a reason why in reality the ball will not travel d meters. Well, this is assuming it has infinite bounces. So I'm just going to put the assumption is ball bounces infinitely, but that's unlikely. Yeah, it's going to bounce for a finite number of times, but this is unlikely. In which case it won't bounce for 20 minutes, it'll be less than that. You could have had other answers here though. You could have said the ball is unlikely to bounce in a vertical line. You could have had there'll be some horizontal motion, which is really saying the same thing. Or you could have even had the old classic of air resistance, which I've never really approved of, but that would have also worked. Okay, an r cos x plus alpha, x minus alpha question. Let's do this one. So, okay, these first 3 marks, you must be getting all 3 of these. If you're not, then you could kiss goodbye to every other mark in the question. So make sure you can get these. Easiest way of doing this is equating coefficients, if you ask me. So 3 cos x plus sine x, well, that's equal to, now r is always that squared plus 1 squared square rooted, so it's going to be root 10. But let's just write it down slowly. R cos x cos alpha. You can use the compound angle formula here, plus r sine x sine alpha, yeah? And then what we can say is, well, our 3 must match with r cos alpha, because the cos x on this side has been times by 3, the cos x on this side has been times by r cos alpha. And so I can say that 3 equals r cos alpha. Likewise with the sine, I can say 1 equals r sine alpha. Now, I've already said, I personally just write down r straight away as 3 squared plus 1 squared, which you're always allowed to do. It's root 10. If you plug that in either one of these, you can easily work out alpha. Make sure you're in radians, because we're in radians. That's what tells me we're in radians. And you get cos alpha is 3 over root 10. And so alpha will be inverse cos of 3 over root 10. And I believe that comes to 0.322 to 3 decimal places. And we're good. Okay, so what have we shown? We've shown that 3 cos x plus sine x is the same as root 10 cos x minus 0.322. Remember, write down your answer once you've found the relevant values, because they're asking you to express that like that. I've expressed it like that now. Don't be lazy or you will easily miss the final mark. Okay, what's that got to do with this? Well, look at this. We've got a 3 cos stuff plus 4 sine stuff. So theta is going to be actually equal to 6.5 plus. They've just plonked that on the start. And then we've got root 10 cos. Now what has x become? X has become this monstrosity in here, pi t over 13 minus 4, and then we're going to take away a 0.322. Well, that becomes minus 4 minus 0.322, which is the same as minus 4.322. So that's what theta actually is, and that will be a more useful form to work with in this. Now, deduce the minimum value of theta. Well, this is the way I look at this. If I can just ignore that bit, actually, let me just take that back. If I can just ignore the bit without the 6.5 plus root 10, just think about cos of stuff. Cos of stuff bounces between -1 and 1. Yeah, it's stuck between -1 and 1. A cos graph is always stuck between -1 and 1. So if you include it with the root 10, then it will be stuck between minus root 10 and root 10. Yeah, and we're trying to find the minimum value of theta here, and so that's going to occur at 6.5 minus root 10. Yeah, and you can just write that down. And 6.5 minus root 10 is 3.34. They would have accepted the exact value though. Now find the time when a minimum value occurs. Well, we want cos of this stuff to be equal to -1, yeah? So cos of pi t over 13 minus 4.322 equals -1. That's what we want. Now, when you do inverse cos on that, it's very easy to get this wrong because you do inverse cos and you get pi, yeah? Cos of pi is -1. And if you rearrange that, you'll get a value for t, and I can't remember what t works out to be, but it is wrong, but I'm going to do it anyway just to show you why it's wrong. Pi, where's pi on my calculator, plus 4.322, enter, times by 13, divided by pi. Okay, I get t equals 30.88 doing it like that, yeah? Why is this wrong? Look at this, just there. That's obviously not the next day, yeah? T is stuck between 0 and 24. So this is clearly wrong. They're trying to give you a hint there. Now, why is it wrong? It's not wrong. It's just the time when the minimum value occurs the next day. To get the time the minimum value occurs this day, you need to know your other values on the cos x graph where you get -1. And cos x looks like this, yeah? And that -1 happens at pi, but it also happens at minus pi. You can always add or subtract 360s, can't you, to cos or sine values? And in radians, that means taking away 2 pi. And so we need or minus pi here, and we need to work with a minus pi one. So cross that out. Now we're just going to rearrange this very quickly on our calculators. We're going to do minus pi plus 4.322, times it by 13, divide it by pi, and then we get t equals 4.88. And if we want that in hours and minutes, times 0.88 by 60, you'll see it's 4 hours and 53 minutes. So we got it to the nearest minute. Okay, find the rate of temperature increase in the rabbit hole at midday. Okay, we can do that. Rate means differentiate every single time, yeah? So I'm just going to be looking at this equation up here, and I'm going to be defining d theta by dt. And so the 6.5 differentiates to 0. The root 10 is going to hang around, but cos is going to go to minus sine, and the coefficient on t is going to pop out outside here, just like it always does when you differentiate. Think about how if you differentiate 3 sine 2x, you get dy by dx is 6 cos 2x. The 2 kind of flies outside. And actually, let's think about it as 2x plus 3. The 3 doesn't fly outside, but the 2x becomes, well, the 2x remains to be 2x plus 3, but the 2 needs to be taken outside. It's the same here, but just much more kind of like, complicated. But, really it's the same principle. So we're going to have minus pi over 13 times by root 10 sine pi t over 13 minus 4.322. And now all I'm going to do is plug in t equals 12, and I'll just see what that equals. And it's a job for the calculator, and it comes to 0.756 degrees Celsius per hour. Yeah, that's a rate of change. Okay, number 9. We've got these values, and we've got to find the smallest possible value of k. Well, we're trying to make the domain as large as possible here, I'm guessing, because it's not actually, I don't like this question actually. I think they should be a little bit more careful about how the way they word that. But if you wanted to make k as large as possible here, if you want to make the domain as large as possible, which is traditional, then you want k to be equal to, if you like, -4, or even better, you want to say, x is greater than -4, and that's just because you can't log a number which is, you can only log values, positive values, yeah? Think about the log graph. It goes like this. Yeah, and so x clearly has to be bigger than 0 here. So the way I'm getting at this is I'm saying, well, the thing after log must be bigger than 0, and therefore x is bigger than -4, i.e. k equals -4 is the smallest possible value of k. Okay, show that f dash of x equals that. Well, let's just write down what f of x equals. It's very poor in the picture. We've got x plus 5, x plus 1 over x plus 4 minus ln of x plus 4. And we've got to differentiate it because that's a dash. So before I differentiate this, I'm just going to multiply out the brackets. It just seems slightly easier to differentiate if I do this. X squared plus 6x plus 5 over x plus 4. And I'm going to need quotient rule for this. No question about it. So f dash of x, right, quotient rule. Low, d high. So that's 2x plus 6, that's d high, multiplied by the low, x plus 4. When I say d here, I mean differentiate. Minus high, d low. So that's x squared plus 6x plus 5 multiplied by 1 over the square of what's below. And that's how you do quotient rule in your head. Low d high minus high d low over the square of what's below. And then don't forget to differentiate the natural log. That's going to go to 1 over x plus 4 because we're going to differentiate inside the function. We get 1. Then we're going to differentiate ln of stuff. Well, that's 1 over the stuff. Okay, now all we've got to do is just put it in their format. So I'm going to times this top and bottom by x plus 4, and I'm going to multiply that out on the top. So we get 2x squared plus 6x plus 8x plus 14x plus 24, but then minus x squared minus 6x minus 5 all over x plus 4 squared. Definitely not multiplying that out because I need that as part of my answer. Because it told me to put it in the form over x plus 4 squared. And now I can just simplify it at the end. We get 2x squared minus x squared, well, that's x squared. 14x take away 6x is 8x, take away another x is 7x. That's all of those dealt with. And then 24 minus 5 is 19, minus another 4 is 15. Yeah, and hopefully I've got that right. I'm just quickly checking my answers. Yeah, cool. All over x plus 4 squared. And you're done. Yeah, cool. Okay, there is a way of checking this actually on your calculator because your calculator will differentiate if you give specific values of x. So what you could do is give a specific value of x and check that your calculator agrees with the correct answer. Come and see me if you want to know how to do that. There's lots of ways of checking in this exam. Okay, hence show that f of x is an increasing function. Why is this an increasing function? Well, let's write it down here. Increasing functions have positive gradients. Yeah, so we need to argue that f dash of x is greater than 0 for all x. Yeah, and it is clearly denominator is always positive. And that's because it's a square. Well, and actually it's strictly greater than 0 because x is greater than -4. So it's always greater than 0 as it's a square. Okay, for the numerator, we've just got to prove that this is always positive, yeah? There's lots of ways of doing this. You could use a discriminant. You could complete the square. I'm going to complete the square. X plus 3.5 squared. Okay, that would be minus 12.25 because that's 3.5 squared plus 15. And you get x plus 3.5 squared plus, is that 2.75? 2.75, I think. And so why is this always greater than 0? Well, because it's always greater than 2.75, greater than or equal to. This is larger than or equal to 2.75. Oh. So greater than 0, so positive. Okay, hence f dash of x is strictly positive and increasing. And, it's increasing. There we go. Notice I write stuff down, yeah, like I write sentences. Don't have to write sentences for every question, but some questions it's obvious you should write sentences. And just to show you that that's the way to do it, can I just quickly show you as well? Oh, like look at this up from the mark scheme. I'm just quickly screenshotting the mark scheme just to show you they like an argument here. You know, the numerator and denominator are both greater than 0. They've written that down. Therefore, f dash of x is greater than 0 and f is increasing. Yeah, they did it with the discriminant. Yeah. Oh no, no, actually, I tell a lie. Look, they've done it just like me. 2.75 there. I think you still need to have an argument saying discriminant is negative, therefore it doesn't cross the x-axis. Okay, and that was the first 9 questions. Thank you for watching, and good luck with the rest of your revision for the real thing. Bye bye.